Earth restoration only works if it can be measured. And the core unit of measurement is not emissions. It is absorption per hectare. Carbon does not disappear because we feel guilty about it. It disappears because living systems bind it into mass. Every hectare on Earth has a maximum biological carrying capacity. That capacity depends on climate, species selection, water access, and soil health. A hectare of restored tropical biomass can absorb multiple times more carbon than a hectare in a temperate zone. This is not ideology. It is physics and biology working together. Fast-growth biomass systems absorb carbon rapidly during early growth phases. Slower systems absorb less annually, but store carbon longer. Restoration therefore requires layered thinking, not single solutions. Short-cycle biomass captures carbon quickly. Long-cycle biomass locks it away. When these systems are combined, absorption accelerates while stability increases. The planetary cycle theory explains why this works. Planets stabilize when mass increases faster than disruption. On Earth, biological mass is the fastest scalable form of planetary correction. Carbon absorption is therefore a throughput problem. Absorption rate equals hectares deployed times species growth rate times survivability times time. This means Earth does not need perfection. It needs scale. A single hectare restored correctly absorbs more carbon than decades of debate. Multiply that by millions of hectares, and the system shifts. This is why focusing on emissions alone fails. Emissions are continuous. Absorption must outpace them. Restoration succeeds when absorption becomes inevitable. Once land is allocated and species are matched to climate, the math becomes predictable. Carbon reduction stops being theoretical and becomes mechanical. From this point forward, every decision must answer one question. How much carbon does this hectare remove and how fast? Earth restoration advances 1 hectare at a time. But when coordinated, those hectares change the planet.